Hey everyone, it's David Bombal coming to you again from Oxford in the United Kingdom. I'm going to call with Hank Preston. And Hank, you owe me. Last time you told me that you're going to show me how to run Docker on a switch. So the pressure's on this time. I'm hoping that you're going to show us that and hopefully some more surprises as we go through this call.
Yep, absolutely. So we ran out of time on our last Nexus programmability talk, but this time we're going to dive right back in where we left off and looking at kind of Bash on the switch, as well as then moving directly into kind of the Docker components and running. And so like last time, I'm logged in here. I'm on a Nexus 9000 switch. I'm using one of our DevNet sandboxes. And so if I do a show version, we will see that we are running on a Nexus 9000V, so it's just a virtual Nexus 9000 switch. Now this is, the Docker feature specifically is something that was added in the most recent release, so we do need to be kind of at that 9.2.1, but our DevNet sandboxes are there, so you can experiment and play around with it, and the images are posted to CCO if folks have their own Nexus switch and they want to load this up and kind of experiment locally on it. And so you can jump right in on that. Now, the piece that we're going to use is kind of leveraging the fact that NXOS, like many networking platforms today, are really their applications running on top of a Linux kernel that goes there. And so one of the things you can turn on your Linux or on your Nexus switches these days is a feature called Bash Shell. And so even Nexus is always running on top of Linux, but in general, most use cases and most users don't need to jump into the Linux underpinnings of the switch itself. Most of the time, you can just turn it on, use NXOS, configure your interfaces, configure your routing. But if you do have a use case where you want to jump in and take a look at the underlying Linux elements, you can turn on feature Bash Shell like you would any other feature. And then once that's done, we'll see underneath this run command, I've got run bash. And so I can say run bash. And now my prompt has switched from the typical Cisco kind of interactive CLI prompt, and now I'm at this bash 4.3 prompt. And so I'm on the switch, but at the Linux level for that. Does that make sense?
Yes. So, I mean, if you type show run there, it wouldn't work. Is that right?
No. Nope, because show isn't a command, run isn't a file or directory. Like it's trying to figure out what to do with those. Like those don't exist. But if I type ls-l, that works as a Linux command. If I type pwd for print working directory, if I do ls-l/boot flash, because we can kind of see where we are in the path here, I can see the contents of the boot flash. So I'm on the same switch. We haven't exited the Nexus application. Like it's still running. We've just kind of moved our terminal out from the Nexus interactive mode into just the Linux under the hood.
Yeah.
Make sense?
Yeah.
Perfect. Now, if you've been doing anything with Linux, like maybe you've got some Linux commands that are there, and so we're used to working on a network device and working with interfaces, so like show interfaces or show IP interfaces. In the Linux world, there's the IP command that lets us look at those. And so if I do IP addr for address and hit enter, it throws them all by because this is a network switch, and we can see it's got 128 Ethernet interfaces on here that go through. And so if I scroll up, we'll see we can actually see all of the interfaces. I'm going to scroll way to the top. And I think we might have hit some of these in our last video, but just kind of review that whole Linux piece. Right here, we can see that there's interface number 37 is VLAN 104. We can see the IP address that's assigned. So again, it's the same switch, but now we're using kind of the Linux pieces to look at it rather than the native ones that are there. But what we're interested in is kind of, what can we do inside of Linux? And so one of the things we can do is we can run Docker on top of this piece. And so when I've logged in initially here to Bash, who am I? We can see that I'm logged in, like the Linux account I'm on is admin, because that's the same account I logged into the switch as originally. I logged in as the user admin. To manipulate and work with Docker, we need to have root permissions for that. We could muck around with the permissions, or we could just do a sudo su dash, which just kind of elevates me from being the admin account to now I'm the root account. So again, just a standard Linux privilege escalation piece. And any questions on that bit here? So I'm still in the same box, just kind of change the account that I'm working as. Is that clear?
No, it's just like standard Linux. Looks
It
exactly
is,
the
yeah.
same, acts the same.
Yep, and I'm always, particularly when talking or working with network engineers, like I don't want to assume too much Linux knowledge that's out there, so I'll try to explain. If I jump through something too much or make an assumption, please stop me. I don't want folks to get confused on what we're doing.
Can you type uname and hyphen what's it all?
Uname.
Sorry, just A, not L. Sorry, just A, as in A.
There we go.
Oh, there we go. So we can see it's Linux, can't we?
Mm-hmm.
Yep.
Yep.
Yeah, it's just to prove that it's Linux. It's not Ubuntu,
it's Linux,
but
and we can
it's
see
some
we're
kind
on
of Linux.
the 4.1 kernel, so it's actually a pretty recent version of Linux on that. And one of the things, and one of the reasons this Docker element that we're going to look at works only, or you need to be on this latest version, the 9 version, is prior to version 9 of NXOS, it was still a Linux kernel underneath NXOS. But it was kind of a more customized Linux kernel. When we moved to 9, we've kind of been trying to standardize, get closer to native Linux so that we can take advantage of some other things like the example we're going to use today, which is Docker that's there. And so before we started, I went through a couple of the steps to kind of get Docker turned on. I didn't have to install Docker. That's installed on the switch when you get it. But the service isn't enabled. So I went ahead and I've already turned it on. So if I do a service Docker status, we'll see that Docker D is running. And so what I had to do to get it started was just service Docker start. I mean, that's how I started it up. It's already been started, so that command didn't do anything. Right now, if I were to reboot this switch, Docker would come back up and it would be stopped. You can go through with typical Linux kind of service administration and have Docker start at switch boot up if you wanted to, and all of that is you do that with typical Linux pieces, and we'll include a link for it, but I'll probably bring it up here in a second, the actual Cisco documentation that kind of walks through enabling and using Docker on your switch and some of the pieces that are there.
That's great.
All right.
Hank, can I just interrupt you for 1 second? I'm going to inject a piece here, if you don't mind.
Yeah, please.
Like you made that point about network engineers not knowing Linux. So I'm going to do a punt for one of my courses. So Hank, just so you're aware, I've got a Linux course that guys might be interested in. So guys, forgive me for punting this. If you don't have to take this, but just so that you're aware, I do have a Linux for network engineers course if anyone's interested in taking that. So it teaches you Linux from our paradigm, if you like, or from our viewpoint rather than from a Linux administrator's point of view. So I show you how to run Linux, say, on a Cisco router within GNS3 and how to do some basic Linux stuff. But Hank, I'm assuming there's a lot of resources available on Cisco as well for guys who want to learn a bit about Linux. Is that right?
So it's actually an area that we're growing different pieces. So we've got a lot of learning materials and examples kind of using Linux and kind of touching on different Linux topics. But it's one of the things that I've actually been interested in. So we've talked a lot about the Network Programmability Basics video course that we've got up on DevNet that's available. And I've got added to the list some additional modules to add to that, or to different additional lessons. And so there's some basic Linux fundamentals. And so familiarity with Bash is something that I want to add into that series. A little bit on Linux networking I want to add in. And so I think we'll continue to see more of those materials and resources hit some of the Cisco resources as well. But it's awesome to hear that you've already got a course out there for Linux for network engineers, because I think that's a topic I talk about a lot. Is I joke that we don't expect every network engineer to become a big bushy beard Unix sysadmin, but we do need to become comfortable with kind of just the fundamentals of manipulating and working with Linux, because of the fact that nearly everything we touch is running on top of Linux these days.
Yeah, I agree. I mean, it's one of those things you just got to learn, I think, as a network engineer. It's you can push against that. It's the same as Python. You can push against learning that. But I think if you want to enhance your career, Linux, Python, the stuff that you're showing us, it's worth just getting an understanding. You don't have to spend your whole life on Linux, but it's good to understand, why not do yourself a favor and not learn Linux? You're only going to harm yourself, if you like, I think, going forward, if you don't learn a bit of Linux, a little bit of Python and so forth.
Yeah, I totally agree. Totally agree. And even, and one of the things that I've done recently, going completely off of a tangent, is I'm typically a Mac user. I've got a Mac OS. That's my primary laptop. I've also got a Windows laptop that I work with, and I bounce back and forth depending on the types of classes, the material that I'm developing. And I've actually gone on that Windows laptop and then dual booted it so that I can boot up into Linux, so that I've got an environment that I can become more familiar with that is kind of true native on these areas. Because passing familiarity, I think, with all of the operating system and platforms is just going to make me a better engineer, because I'm constantly kind of confronted by one or the other as they go through. So.
Yeah, agreed. I mean, I'm the same as you. I work on Linux, Windows, and Mac all the time. And I think, guys complain that there's so much to learn, and that's true. I think it's, network guys have become more generalists in some ways. There are obviously roles where you're very, very specialist, but I think it won't do you any harm to learn a little bit outside of your traditional routing and switching. So like virtualization is another thing that you should learn, I think, as well.
Yeah. I mean, that was one of the first places where I thought that I was really adding some value when I started at Cisco many years ago, was having discussions with some of my customers, trying to help the networking team and the server virtualization teams kind of better understand what it took to integrate the two worlds together. And because the networking team at this particular customer didn't have a lot of familiarity with virtualization, and the systems team didn't have a lot of familiarity with networking, they were struggling to kind of bridge the gap. And because I'd had a bit of experience with both, like, it was one of those things I was able to help kind of translate between the VMware world and the networking world, and help kind of resolve some of the challenges that they've been having for a while. And I think that's a role that network engineers have often had, just because of the nature of what the network does. But it gives us a really good opportunity, because we do provide the connective medium between everything in IT that's out there. And so I think we do need to have a bit of understanding about kind of these other domains, because it makes it easier for me as an engineer to understand why somebody needs the network, or how they're using it, to kind of get just a little bit of kind of entry into their world. I'm not going to become an expert in software development or in databases or big data, but to kind of get some of the basic fundamentals kind of just help me in my day-to-day job.
Yeah, I mean, I think that's true for many domains, including, programming. We may not want to be full-time programmers, but you as a network person, and I don't know if you agree with this, but you need to perhaps interface with a full-time programmer and explain to them what the program should do. So you have to have an understanding of programming. Hank, I hate to throw stones, but I just saw on the news that they reckon one of the issues that happened with WebEx recently was because some guy ran a script that deleted a bunch of VMs. And I mean, there's no better way to mess up a network than to run something that's automated when you're not quite sure what it's going to do. So automation is a really quick way to mess up a network, and I could use worse words than that. But it's really important that network guys understand a bit about programming, so the programming guys don't just do stuff without understanding what they're going to do. Sorry, go on.
Yeah, I mean, that we did have a pretty painful WebEx outage, and I don't know the full details for it. I've probably heard a lot of the same stuff that you've seen that was out there. It does look like it was some automation that had gone awry. Yeah. And that's one of the pieces I hear so much from people that are fighting against automation is, we can break things so fast. And I'm like, yeah, you can. Like, that's true as things are going faster. But things have always broken. We've had to figure out how to design and protect against those. And I don't think we'll ever get to the point where mistakes stop happening. Like, we'll always have that potential to go through, which is why understanding how to program effectively, how to do proper testing, having environments to test in, before you ever get close to what we would consider the production, kind of the main network that goes through, will be critical. I would never recommend anybody go through and say, I'm going to write a script that automates some part of my network, and then I'm immediately going to go run this against my entire environment. That is a recipe for disaster. You have to walk through some of these pieces. It's the same thing I did back before Python and ease automation, when I would write change plans for the network and say, okay, I've got this set of commands that I need to run, and I'm going to have to run this on every one of my switches, and I'm going to need to do it as quick as possible because I have a limited amount of time for the change window. Weeks before, or at least days before the change window shows up, is I've tested those commands over and over again on lab systems and areas to make sure that I understood what they were going to do. So my confidence level was as high as possible. With automation, that just becomes so much more important.
Yeah, I think it's an opportunity for a network person. For those people who are prepared to learn this stuff, there's a massive opportunity now because you can be that interface like you were in that example you used previously. You were the interface between the network guys and the virtualization guys. Now you can be the network guy who understands programming and be the interface perhaps between full-time programmers, or just add a bit to the networking team. I think it's an advantage and an opportunity rather than something to be scared of.
Yeah. I mean, I got into IT and into networking because I like learning stuff and figuring things out. And I think we just got to keep that in mind as we go through. There will always be lots of stuff to learn, and I find myself very regularly these days saying, I getting a question and saying, I don't know, I haven't had a chance to look into that really deep. And even hearing that from some of the other people that are in the social world, kind of the network engineers, the folks that we all kind of like look up to. Occasionally you'll see someone post on Twitter or LinkedIn and say, hey, I just started looking at this. And I was like, wow, they don't know it all either. And I think that helps with everybody that's out there recognizing that I don't know everything. Nobody can know everything. We kind of pick and choose, and we just continue to add to our toolkit of skills and capabilities as needed and as time allows.
That's great. Yeah, sorry to digress, but I think it was a good discussion.
No, good. I always love our tangents. I learn a bunch, and it's just kind of fun to chat. So, all right. So back to where we were. So again, I'm on my switch. We've seen that the service for Docker is running. And so let's just try to run kind of just a basic Docker container. So I'm going to do Docker run, and then I'm going to do IT. And so this is interactive terminal, so I'll be able to connect into it. I think it's just one dash. Now I'm trying to remember these commands off the top of my head. And then I think it's --rm. Let's see how well I did here with remembering this. And then Alpine is the name of the container I'll run. Oop, and I got it right. And so what we see here is my prompt changed. I was on root SBX 9K. I ran a Docker container. And so now what I'm in, because I gave it this -I, which stands for interactive, I want to interact with the running container. And then T means give me an active terminal. Those are general Docker kind of functionality and commands. The --rm says after I exit out of the container, delete it so it doesn't kind of stick around any longer. But now I'm in a Docker
uname
container.
again, Hank. Sorry to just before you go, the commands go off the screen. So uname -a again, so we can see that it's a different version of Linux.
Oh, okay, yeah, sure.
Sorry, man.
No, that's great.
Yeah, so we can see it's different to what we had previously.
Yep. So we've got those there, and so now I'm in the Docker container and running. And Alpine, if folks haven't seen that yet, Alpine is just a kind of a distribution of Linux that was designed specifically to be super compact, super lightweight for containerized pieces. So a lot of people build applications, and when they build a containerized application, they start with an Alpine image because it's small. It doesn't have a lot of the when you install like CentOS or Debian, you get a bunch of things that if all you're doing is building a container for an app, you don't need all of those pieces. And so Alpine's this really tight piece, and that's kind of what I'm running here. Is I'm inside the Alpine container, so I could do stuff in here if I wanted, or I can just exit out and see now I've ended my container and I'm back here. Let me do this. I'm actually going to run.
I wanted to. Sorry, I keep interrupting you today, so I apologize for that. I wanted to just. Before you continue, unless you're going to talk about this later, but why? Why do I want to do this?
Oh, why would you run a Docker container on a switch?
Yes, why?
Yeah. So we'll get into some of the use cases for those, but fundamentally it comes down to is that network infrastructure, switches, routers, all of these pieces, these are edge devices that we have spread out across our entire network. And traditionally, this piece of equipment has been treated as kind of a very specific thing. It's a network switch. All we do with it is we plug in cables, and it switches traffic around and provides connectivity back to some data center where we've got applications or different services that are there. people are recognizing more and more that a switch and a router is just another piece. It's like a mission-specific type of compute infrastructure. And because it is a compute piece of infrastructure, we could use it for things other than just kind of that switching or routing functions that are there. And so what else could we do at the edge? And so one of the examples that comes up a lot is folks are trying to gather lots of telemetry information about systems. And so this is often an IoT play is I've got a switch and a router out at a location, maybe a manufacturing plant or someplace on the side of the road at a location, and we're gathering details about weather and temperature and how well our machines are functioning, or maybe telemetry from vehicles. And we want to kind of do some initial processing, crunching those numbers before we send that up for final processing in the data center or in a cloud someplace. Oftentimes, if we take the raw telemetry information, that can be a lot of data, and trying to send that over expensive and slow and latent links. And so edge processing is becoming an important part of IoT strategy. To do edge processing, you need some place to run the processing code. And so we've seen some use cases of things like containers on switches or running applications on switches and routers. The idea is I need a switch anyway. If I use that switch or router as just a hosting environment for some application code. And so that's one use case where we're just running some application code at the edge because we're using the switches and routers just as an edge compute node. So that's one. That type of use case typically doesn't have a lot to do with network functions. But there's another use case that says, okay, and this is a big thing that comes up in the SDN world, is I have some switches, I have some routers, I have some equipment from a vendor like Cisco or some other networking vendor, and it does 99 or 95% of what I want. But there's this extra bit that I wish I could do as part of my network. Maybe it's some operational task. Maybe it's some network monitoring and reaction task that I want to do. And so one of the things that a lot of us are using is using our Python skills to write and run scripts that can kind of operate or troubleshoot or gather data or do something else in the network. And so let's say I write that Python script and I just want to distribute that and have it run for occasionally to gather stats or be a troubleshooting toolkit that I can use to gather information as part of my workflow. Well, if I can run that application right on a switch, well, and then in our example here, Docker, put it in a Docker image and run it as a container, now I give it this portable ability to kind of bring my networking toolkit, my automation toolkit with me, and I can run it on the switch rather than having to try to figure out, well, is there a server or is there a workstation at that site that I can connect to and run pieces? Now I've got the chance, well, I can run it right from within the network because I can run this code, I have access to it. Those are a couple examples, but I mean, if what we're at the end of the day doing is just treating these network components as just another place to run workloads and systems and applications and services, and the types of applications and services are kind of as wide open as your mind and creativity can take it.
I think it's really a paradigm shift, isn't it? Because in the past we had like iOS, classic iOS. It was like a closed system, if you like. But here you've got a router or a switch. As you said, it's basically a Linux box, and you just trying to break down the components, and you're booting Nexus OS as an application. But this allows me to boot a Linux operating system basically in a container. And then I'm kind of running a Linux, I wouldn't say VM because it's not a VM, but a Linux PC for lack of a better word, but it's a container side by side with the Nexus OS. Is that kind of right?
Yeah, so there's a lot of pieces that are in there. What's interesting now is there's lots of different ways to get a Linux environment inside of the network. The one we're looking at now is we've gone from we're active on the Linux environment that's kind of at the base. And so if we picture that physical switch, and in this case it's a virtual, but if you picture a physical switch, the first part of powering that switch on is starting the Linux kernel, loading drivers, getting all that stuff done. And then at some point in the boot process of that switch, NXOS starts, the NXOS daemons, the applications, the processes to control layer 2 learning and forwarding and routing, like all those things start up eventually. What I've done in this case is say, okay, well, I want to get down to the Linux and run some other things alongside the network operating system that's running. In our case, it's NXOS. There's another thing we can do, and we'll show the.
Sorry, Hank, I keep taking you on tangents, but I'll put a menu up so that people can, decide what they want to watch. Yeah.
We'll see where we're at. I'm gonna exit out. So the first exit I did took me from the root. Remember, we did privilege escalation to root. Now I'm back. I'm still in Linux, but at that admin user. I'll exit again, which brings me back to now I'm in the Nexus, the CLI that's there. When I did this run command before, we did run bash, but there's also run guest shell. What guest shell is actually a little bit more similar to one of the things you said, which was that we were running Linux as like a VM or a container on our switch. That's what guest shell is. And let me see if it's actually enabled on this one. Guest shell. Let's see if it starts. So yeah, it did. So now see my prompt. So we've seen a bunch of different prompts. So when I did run bash before, this was the prompt I had, and we can see I was root at SBX N9KV. That's my switch. Now I'm admin at guest shell. What guest shell is actually a containerized version of Linux. And so remember, I don't even know if the IP command, I don't know, it works there too. So, but one of the differences between what we saw before and this guest shell one is now the guest shell is actually a container, a Linux container, similar to what we did when we started the Alpine container. Is guest shell is kind of a native Linux container environment that ships with Nexus. It also ships with iOS XE, and so that you could run Python code and pieces in there. The big difference, or the big differences between them, is when I'm inside the guest shell, I'm isolated from I'm not on the same Linux kernel and platform and process space that NXOS is in. I'm segmented. I'm secured off from NXOS. And so anything I run in guest shell would run like Linux processes. I can run Python scripts. I can run utilities that are in there, but I don't have access to the same process and memory space that the Nexus operating system, the NOS, OSPF, BGP, like I'm isolated from those in its own type of a container that's there. And there's use cases for both. If I want to run something and want to keep it protected and don't need access to the underlying kind of Linux functionality, running in guest shell is kind of a safer place to put it. But if I want to run an arbitrary Docker container for some application, I can't run a Docker container inside of guest shell. We would jump back to bash and then run another container on there. And so it's kind of where you want to put stuff. And I'm afraid we may have gotten a little bit too kind of complicated for a verbal description. But does that make sense, David?
Yeah, I'll see, Hank, I'll try and put up some pictures. If you've got any good pictures, otherwise I'll look on Cisco's website. But yeah, it makes a lot of sense. So you've got the underlying kernel. So when you exit out of the Nexus operating system, you're jumping down or dropping down into the underlying kernel, and then you are booting up Alpine Linux as a container off that. But here you went straight from the NOx CLI into guest shell, which puts you basically into a different container as well.
Yeah, in the idea that a picture is worth 1,000 words, I'm going to just bring up kind of a raw drawing here and see if we can kind of describe some of what we've seen. And so if we say, I'm going to draw this, you're still seeing my drawing here, right?
I am, yeah.
All right, so let's say that this represents my Nexus switch, okay? And we'll say that that's from like the physical layer. Like I have a device. The way that the switches are built is it starts out with there is Linux. Is that writing big enough? Can you read that? Okay.
Yep.
Okay, good. All right, so we've got Linux. So Linux is kind of the underpinning that's there. Running on top of Linux is NXOS. And so that's running on top of the Linux that's there. When I did run bash, what I did is I went from, I'm thought process changing or thinking through how this is going to go. That's what I want right there. And so when I did run bash, I went from, where did my line go? Run bash took me from NXOS back to Linux, right?
Yep.
And so I initially SSH'd, I was in NXOS, run bash took me into Linux, okay? And let me give that a label. Hopefully this is going to help more than it's going to hurt with all of our pieces.
No, I think this is good.
Okay, so run bash took us there. When I was in the Linux environment, we started that Alpine container. And so what it is I'm actually going to do it this way. The first thing we did is we started Docker. So Linux is our underpinning. NXOS is running on top of Linux. I was able to start Docker, and then I was also able to start an Alpine container. Our sizes are going to get really weird. And so when I was from Linux after run bash, I started my Alpine container, and then I was inside of the Alpine piece that's there. Follow so far?
Yep.
All right. What also is running, and Guest Shell was already running on the device, is Guest Shell. And I honestly haven't looked. So prior to 9.2.1, Guest Shell wasn't a Docker container. It was something called an LXC, or a Linux container, which is another container technology. I don't know if they've now moved it that Guest Shell is an actual Docker container. So I'm gonna assume it's not, because that's what it used to be. But when I did, where's my arrow button here? When I did run Guest Shell, oops, that's not gonna work for me. This is why I don't do Twitch TV. Is because when I'm thinking on the top of my head, it never works the same.
It's tough.
As I expect. Come on. Oh, I'm in the wrong key. There we go. All right,
But I'll edit it, Hank. Don't worry.
Oh, that's fine. Keep it all in there. I think it's good shape. All right.
And sometimes it's nice, to see all the mistakes, because it's like live.
Yeah. So run bash took me from NXOS down into Linux. Run Guest Shell took me from NXOS over here to this Guest Shell container and put me in there.
Yeah.
And so when I'm inside of Guest Shell, I've got Guest Shell access, and as we saw, Guest Shell still it's mapping in kind of like data port access, and so you could you could write a script inside of Guest Shell that could grab stats or look at data that's coming in. Like, there's lots of use cases for that. But run Guest Shell brought me over here to the Guest Shell piece. There's no way to go from, in general, there's no direct way to go from NXOS into the Alpine container, because that's running kind of as a separate process. There's some commands stringing together you could do that could probably make that work. But to get to the Alpine container, we go from Linux up into Alpine. Guest Shell is this parallel thing that's running that's there that gives me access to it. And then alongside here, on top of Linux, we could also run, and this is one of the things that have been popped up as an example of kind of having access to Linux under the hood, is you can run, I think most of the audience is probably familiar with Wireshark, right? Wireshark is an application. You can run that also on Linux. And so one of the things we can do if we jump from NXOS down into Linux is we could run Wireshark and do packet captures from the interfaces on the switch, or gather PCAPs, or look at TCP dump, is because we're running on there, on that piece. So hopefully this kind of basic little drawing and spur of the moment piece will help with some of that discussion we were having with the differences between what we're looking at on that.
Yeah, that's brilliant. Like you say, pictures 1,000 words, as they say. That really helps.
Mm-hmm.
So Curveball, does Wireshark run within Docker, or does it run LXC container, or is it something weird?
I honestly think you could probably run it in any of those if you wanted to. Wireshark is just it's an application that goes through. It's probably not loaded. So I'm here back on my switch. I'll do run bash. Yeah, so Wireshark isn't there, but TCP dump might be. TCP. So TCP dump is right here, installed kind of in the underlying Linux piece. And so I could run that there. So here's a case where you can see no permission to go through. So if I went sudo and then back in, or experimented with the interfaces that were there. But like this TCP dump where I'm running that is, if I go back to my drawing, I'm running that right here within the Linux environment. If I went into Guest Shell, I could put TCP dump or Wireshark inside of that Linux environment and run it from within there. That would be another option. Potentially, we could do the same thing inside of a Docker container that's running as well as it goes through. So it just kind of, because each one of these, Alpine, Guest Shell, these are just other Linux environments. Anything you could run in a Linux environment, potentially you could run into one of those areas. And one of the big reasons around containerized technologies like Docker and Guest Shell and LXC is for process and isolation. If I run something right on top of Linux, it's running in the same kind of namespaces and security zones, memory space that's there. And so there's potential risk for one application or something you do to impact something else that's out there. By containerizing those, you kind of put walls around them, protect that piece from impacting other pieces. You can have different, we talked about this on our container session weeks and weeks ago, if not months ago at this point, where one of the reasons behind containerized technologies is dependency isolation. So if I've got two applications and they have conflicting dependencies, maybe different versions of Java requirements, containers let you kind of put them into different buckets and go through. And so there's lots of reasons that folks use containers for application deployment. Make sense?
That's great. I mean, it's interesting because you've got Nexus switch there, but it kind of looks like a server.
Yeah,
but it's like it's giving you like server capability right in the switch.
Yeah, I mean, I'm not to the point where I'm gonna replace all of my servers with switches, but because it's a mission specific piece of compute. Like there's hardware in it that's dedicated for forwarding. There's switching ASICs in there. It does have an Intel chip, but it's not a server class Intel chip that I'm going to want to run. Like I'm never going to run ESX or a whole bunch of virtual machines. Like I'm not going to replace a virtualization farm with this, but you can actually run with some network infrastructure VMs on there using like KVM hypervisors and things that are there. And there are some use cases for it. But if the primary purpose for a device is running VMs, well, I would use a server. In this case, the primary purpose of this device should be forwarding packets and acting as a network, but I can also do these other pieces on there. And so I always start with what's the main goal of this piece of equipment? And then we've got that solved. What else can we do with it for efficiencies purposes or things like that?
That's great. Thanks, Hank, for going on that tangent. That helps a lot.
Yeah. We've gone all over. So let's get back to where we were with some of the Docker pieces. So I'm gonna privilege escalate back to root. And so before, what we did is we ran the Docker container and I ran it in interactive and then I deleted it immediately. What I'm going to do is run the container again. And then now if I do docker ps-a, what we can see here, so docker ps, again, this is just a regular command. It stands for Docker process. So show me the Docker processes. The -a includes any processes that have ended. Without it, it would just show currently running ones. And so here we can see I've got this, it rolled over on my screen wrap, but this is the line that represents that Docker container. We can see it was created 4 seconds ago. It exited 3 seconds ago. If I run the docker run command again, I'm actually going to run it a few times. And so what we can see now, if I rerun the PSA, we can see that I've got 3 of these Docker containers that have been started on on the piece. And so they're there and they're running. So we've seen that I can run a Docker container on the switch. Make sense?
Yeah.
Okay. Yeah. Let's run an actual.
Start so quickly.
Go ahead.
Sorry, go on. I was going to say we've discussed this before, so I don't want to go over it again. But Docker containers start up really quickly.
Yes, but typically they will. Now you can build the Alpine image that we're using here. There's not much to it, so it starts really quick and it builds really quick. The more complicated the container, the more whatever it does, they can take a bit longer to build and stuff like that. But in general, they're still pretty quick. I'm gonna look. Let me see here. env. Okay. So what I'm gonna do now is let's actually run a Docker container that does something. And so I'm gonna bear with me while I set up for this for a little bit. So what I'm gonna do here is. So what we're going to run is we're going to run a chatbot. And so probably by now most folks are familiar with some sort of like different chatbots that are there for maybe Facebook Messenger or Slack bots or WebEx Teams bots. And so I'm going to run an actual chatbot inside of a Docker container right here on my switch. And to save myself some time, I grab the commands I need to get this done. So I want to make sure that I'm doing some checks here. Oh, no, it's IP. Okay, yep, it's still running. I'll explain kind of how the pieces work in just a second if you're trying to figure out what that command was I just ran. All right. Okay. So run. All right. So I just ran another Docker run command. So Docker run, just like we did before. I'm naming my running container MyBot, and so it's a chatbot. Chatbots, they're an application that interacts with some sort of a cloud chat service that's out there, and so we need to provide this application information about authentication and address stuff that's there. And so all these -e's represent environment variables, and environment variables are something across all operating systems, and it's like a variable with some information. And so I'm passing a URL where the bot is running, a token which represents the authentication information for this bot, the specific bot's email address, what I'm going to call it as name, and these are just being kind of pulled in from environment variables that I set up that's there. Now this bot is running, it's a little Python application that provides a REST API, and that REST API is exposed on port 5000. And so this command here says, okay, take port 5000 from the running container and map that to port 5000 on the host environment, which in this case is our Nexus switch and the Linux environment that's there. The container name, or the container that we're using, is one I built, and it's the Norris container. It's actually a Chuck Norris joke-telling chatbot is what this bot does. And then this output at the bottom is just the identification for the running container. And so when I do Docker PS now, we can see that I have a running container that's currently up. It was created a minute ago. Its status is it's been up for about a minute on that. So before I go any farther, any questions on kind of the start process that's here so far, David?
No, I just want to make a point because I sometimes get comments like this. This is an example. This is not necessarily, obviously, it's something that you'd run in production. You're just showing an example of, technically doing something.
Well, so having our switches tell Chuck Norris jokes, that's not production worthy, though it's kind of a nice Easter egg to put in. But running a chat bot on a switch is picture, there's a concept called chat ops that's kind of in the big DevOps space that goes in. And the idea around chat ops is we spend all of our lives inside of these chat frameworks, talking with our coworkers, kind of getting work done. And the idea is, well, what if our tools, what if our processes could participate with us in our chat rooms? And so imagine a world where all of your switches are friends in your chat program. And so when you're trying to get information or if something interesting happens on a switch, the way that we find out about those today is maybe it sends an SNMP trap or there's something else that goes on. But what if it just, every time a switch had a new CRC error or if a port went up and down, it dropped a message into the chat room for network operations and said, hey, we just had this port just went down on me. And so there's a network use case where running a chat bot on every one of your switches, I think that there's really is some production value for that. Is now, and maybe it's just a push mechanism where we run the bot monitors the switch state. Anytime certain activities happen, they just send messages and say, hey, message from switch 2, this trunk port just went down. And then a couple of seconds later, it's back up. And so now you've got this log that things go through. You can take it the other way where you could say, hey, switch 1, what's your current memory utilization? Or what's your routing neighbor table look like? And so rather than normally we would SSH to that device, run the command, Well, now to do that, we kind of get out of our workflow. We move from one program into another, where if we could just do that and kind of ask the questions directly. So there are some real networking and production use cases for chat ops inside of the network. The hokey use case of telling Chuck Norris jokes or cat facts or things like that use case isn't there. But the fundamentals of making your network devices part of chat ops, I think that there really is some good functionality for that. Does that make sense?
Yeah, that's interesting. So like if I'm in Slack, I would be able to talk to the switch basically, kind of thing, like as if I'm talking to a coworker.
Yeah, absolutely. Absolutely.
That's great.
So in this case though, like I said, and as I was putting this one together, I teach kind of concepts of chat bots and how to build them and go through. So I just grabbed one of the ones that I had, which is this Chuck Norris one. And so it's running on the switch. And so if I go, in this case, it's a WebEx Teams, which is like Cisco's version of Slack. And I can say hello to my switch. And because I just started it, sometimes you have to like wake it up a couple of times before it starts responding. There it goes. We can see that a joke came back. So this is actually interaction from my switch. And so I, on my chat client here, said hello to my switch, and that bot is programmed anytime anybody says anything to it, just to give it a Chuck Norris joke. And so we can see Chuck Norris can do a wheelie on a unicycle. And so my switch has now actually joined my chat conversation. And you could provide, like we talked about, more functionality where it's not just telling jokes, but real use cases for that. And over here, when I flip back, we can actually see some of the remnants. These are just messages about some of these connections coming through. If I look, remember Docker PS, we can see my bot is there. There's another Docker command called logs. So Docker logs, and I can say, give me the logs from my bot. That's the name of the running container. And when I run this, we can actually see, it looks like at one point here, this first one had an error that went through. I'm going to send another message just so the error goes away a little farther up the line. So hello again, and then run the logs. Here we go. So what we see here are the logging messages showing that my bot actually received a message from hapresto@cisco.com. That's my account in the chat system. And then it sent the responses back. And there's just some error code that popped up in here at some point for something. But down here at the bottom, these are the actual messages going through. So we can see two messages. If I say, hey again, we'll see now I've got a third message that came in here with the message alert. And so now I'm actually interacting with my switch at the edge that's there. And we could, again, write our Python code to do things other than just tell jokes. Make sense?
Yes, that's really interesting. So if you go back to is it your WebEx client, is it?
Yep. The WebEx Teams client, yep.
Sorry, the WebEx Teams client. So this is, again, like Slack for people who haven't used this. And you basically, through that chat program, sending messages to your Docker container running on a Nexus switch, and then it's sending something back. Obviously, it's just jokes, but like you said, you could write it somehow to query an interface.
Yeah, and if I scroll up here, you'll see I've actually used this bot for different pieces, and in other cases, I had it providing information. So I had up here said hello, and rather than saying jokes back, it actually was providing like interface information. And so it's just the bot code that I'm running now just isn't written to do that. It's written to tell jokes. But you can see here's where I'm actually getting network information about the interface status from a device. I think in this case, this was a Catalyst switch when I was running the bot that time. So again, whatever you can do through automation, you can kind of wrap that up in these types of bot pieces to go in.
Yeah, so that's actually quite a paradigm shift. I mean, now that you've shown us this, again, pictures worth 1,000 words. It's quite amazing. So just from the chat program, you querying that switch, you're getting stuff back rather than having to go and open up PuTTY, SSH to the switch, do a show interface or something, and then trying to get the information out. You're doing it directly from within this chat program. Mm-hmm. So the next question is, Hank, so hopefully you've got a course somewhere or something that shows us curious people how to do this now, or how it works, because you've shown us the result, but how does it actually work?
Yeah, so it's a good one. So one of the there's a series that we're running. We started this fall of what year are we in? 2018, called NetDevOps Live. And the last session actually in this first season, which happens at the end of November, I'm leading a lab on building network chatbots, and kind of the whole lab is builds up to doing this. And so walking through the components, how to build and build the chatbots. We'll do the same thing we did in today's session, is put it in a Docker image, run it as a container at the edge. So that course is coming up at the end of November. My plan is, at the end of November, I'm running it live, but I do plan to kind of turn that into something that's more of an on-demand type of a piece, so people can kind of take it as it goes through. So today's video is a bit of a teaser for kind of that material that's going to kind of come out and help folks build through how all of these pieces work.
So once you've done that, Hank, could you give me those links? So I'll update the links below this video. So for everyone who's watching this, if you're watching this in November or October 2018, it's not ready yet. But if you're watching it later, hopefully the links are below this video. Is that okay, Hank?
No, absolutely. Yeah, no, I'd love to go through and get them out there, because it's and I'm still working through kind of the specifics of how the lab will go, but we'll probably start with something that's kind of fun, whether it's Chuck Norris jokes or cat facts or weather information. But what's interesting about building chatbots, and why I start with something kind of fun like this, is once you understand the components that it takes to build a chatbot and you have it running like we do now, adding additional functionality and commands so that the bot can do things other than just tell jokes is actually quite simple. It's just a matter of, okay, well, what's the code that I need to do to grab interface health? All right, so you've probably already written that in Python someplace, because lots of us are building those use cases. All we do now is we wrap it up kind of in the bot wrapper so that you end up with like a command structure. And that's how a lot of the bots work, is when you say hello or help, it replies back and say, hey, here are the things that I know how to do. And you execute or you activate one of those commands, and it goes and performs that action out there.
So you could, through this app that you're going to show us, well, in your other course, going to show us how to do, just to summarize, I could have a Slack application or WebEx application, and I could say, hey, switch 1 or hey, switch 300, whatever it is, and then say which interfaces are down, or what's your IP routing table looking like. So rather than having to SSH to each one of these devices through this one interface, I could be querying multiple switches at the same time. Is that right?
Yeah, absolutely. And that would be kind of the use cases. You could have one room called network chat ops, and all of your switches are in there. And when you go in, you could pose a question just to one switch. And so it's the same thing as like if we were in a big chat room, a Slack channel or a Teams room, and I wanted to ask you, David, a question, I would @David and then say, hey, what's your schedule look like this week? If I was in a big room with all my switches, I would @switch1, what's your routing table? Or I could go through, and the way Teams works is I can do @all, and it would tag all of the switches and say, hey, what's your routing table? And then every one of them would process that command and send it back. And so it's just that way to interact. Mm-hmm.
Yes, I mean, this is an example of a use case. Some guys, the cynical network guys, would say, well, I've got a management system to do this kind of stuff. But this is just an example of what's possible, because that switch is running Linux and you've run a container on it. And you said there were some other use cases you had as well that you could show us. Is that right?
Well, yeah. So once it's there, we can. There's so many. There's no end to the use cases that are there. I've had examples. One of the let me switch back here. So one of the big examples I've done for talking about running anything at the edge, whether it was in a container or just a raw script, is I call it the save me from the blue cable. I used to have better names, but I'm drawing a blank on what it is. But how many times have we ever made a network change on something and then did something wrong in that network change? Network guys never like to admit that we've ever made a mistake, but I've made mistakes like the best of them. Maybe shut down the wrong interface. It changed a VLAN that I wasn't supposed to. And so one of the big use cases I talk about with running from a network perspective and operations perspective of code at the edge is you can monitor a switch for every time a configuration change happens, right? A syslog message gets stamped every time a config change happens. And so the use case I talk about is let's build something that monitors for the config changes to happen. And then every time a config change happens, have a set of tests to run from the switch. And so things like, okay, are my uplink interfaces up as they should be? Look at the routing table. What's my next hop route? Can I get to it? Can I reach the DNS servers? Can I reach NTP? And so run through all these things that kind of the goal being, hey, a configuration change happened. Am I still connected to the rest of the world? And if not, roll back, like whatever config change just happened, like undo that, because clearly something happened that shouldn't have happened. And so now if I, as a network engineer, make a mistake in the config, within a few seconds, that switch notices the config was changed, notices there's a problem now, and then rolls itself back. The reason we have to run that at the edge is because that's not code that you could run from a management system. That's code that has to run at the edge, because the whole point of that piece is that switch has been isolated because of some incorrect configuration that was done. And so for me, that's a great use case. It's one of the first ones I describe to folks when they say, okay, well, what can I do why would I want to run a Python script on my switch? Well, run your network health check, write one, figure out what it takes to make sure the switch is online, and then just monitor the syslog. And every time a config change happens, run through this. And if you've lost connectivity, roll back. And to me, that's like the first use case. If that's all I ever did with running applications and code at the edge, that would probably save me tons of potential network down or network degradation use cases.
Yeah, it's a great example. I mean, you have to run the code locally because if the switch is isolated, no management station could get to it.
Right.
And that script is just monitoring syslog, is that right? So when it sees a change, checks what the change was, rolls it back if there's a problem. That's great. Yeah,
I mean that's one example. To the cynical network engineer that says I've got SolarWinds or I've got these other things that monitor my state, if that fits in and that works for your use cases, that's great. We have more and more, and I see this in my own life, right? I spend my time interacting with people and systems and going through. If I've already got Slack or WebEx Teams or Microsoft Teams or one of these things open, and I'm interacting with my team, working on a project, tackling my help desk tickets, if in that same environment that I'm already there, I'm getting notifications about stuff that's going on and updates, that streamlines my own workload. The notifications wouldn't have to come from the switch like we talked about. I mean, you could build those bots to kind of come from your SolarWinds system or from your network management system to come in. It's a matter of figuring out how to go through. The idea around ChatOps is about kind of letting people stay where they are and giving them the information about where they are and letting them do more from these single tools that are there. Not every organization is adopting that, but the ones that are trying to figure out how can we get more and more stuff kind of embedded. There's integrations for just about every cloud service and collaboration tool into these chat systems, where I think we've talked about Git before. You can have, every time somebody makes an update to a Git repository, you can have the Git system can notify a chat room. So the team that's working on that project can be notified that, hey, Hank just pushed some new code, or Hank just opened a new issue. And again, I don't have to go to email or go to GitHub to find out that issue is open. It told me right in the system that I'm already at. So now, granted, there's an argument to be made that that's a bit too much information overload, and sometimes it's good not to be given like immediate notification about stuff. But for things that you do want to know about immediately, it's kind of nice to get it in one place rather than having 17 different windows open for different types of purposes. But I mean, some of this just comes down to personal opinion and preference. So,
yeah, I think you've hit it right at the end there. I mean, I think one of the things I've learned as I get older is everyone's different and everyone has different requirements. And just because it's something that you don't want or don't like, it doesn't mean that someone else won't like it. And I think a lot of us, it's easy as a human being to say, look, this doesn't apply to me, so it applies to no one else. And that's a very small-minded attitude, I think, because different people have different requirements, and what works for one might not work for another. And this just gives us more options, which is great.
Yeah, absolutely. Cool. I think I've kind of gotten through it. So the challenge you set me out with when we first started here was, can we run Docker on a switch? And as we've seen, I think it's still running here, we can indeed. Right at the edge on my Nexus switch, I'm running a Docker container. In this case, it's a chat bot, but it could be an operations tool. It could be an actual piece of application code. Kind of whatever you could think of is what you can do with these types of capabilities.
That's great. So just to summarize, Hank, we've got could you go back to your picture, that one that you drew dynamically, and just summarize what we've done? You've got Linux running on a Nexus switch. Mm-hmm. And, well, I'll let you do it. So what else have we got in those pictures?
Yep. So our Nexus switch, and we've dealt with Nexus today in the call, but iOS XE, iOS XR, I think most of the vendors' network equipment now, kind of under the hoods, is Linux. And then on top of that Linux operating system, NXOS, or your network operating system, is installed and running. And with our case here, we can also now run Docker on Linux, and then with Docker run different containers. And so we saw Alpine, and the other example, I'll throw it in here. We've also seen our chat bot, right? So we've been able to run different containers on top of Docker. Nexus also supports Guest Shell, which is kind of a native container, Linux container environment. And the value of having both direct Linux and Guest Shell access is that if I run something and I want to keep it protected and reduce the chances of impacting other things the switch is doing, like forwarding traffic, by running inside of Guest Shell, it's got a level of isolation that's built into it. And then we didn't run it, but we've talked about how you can run other Linux utilities, things like Wireshark or TCP dump or any of these other pieces, right on top of Linux, kind of as another process.
That's brilliant. So Hank, I suppose we're out of time. I want to thank you so much again for, fielding all my questions and, the cynical network engineer type stuff and, just explaining all this new way of doing things. It's a real paradigm shift from, enable, conft, and so forth.
Yep. Yeah, absolutely. No, it was fun. And it let us finish up the discussion we had in our last video on Nexus programmability. And if you haven't seen that one, remember, go back and take a look. We talked about NX API. We talked about how you can use REST APIs or CLI-based APIs to interact with your switches. We still haven't hit every programmability topic on Nexus, but we've hit a bunch of them and hopefully we've gotten folks interested. And we'll be back with our next topic soon.
And just to reiterate the point, Hank, because some guys have asked this, how do they get more detail? We're just covering high-level stuff here, so I'm assuming there's a lot more detail on DevNet, is that right?
Yep. So we've got, so there's the official programmability guides, the API guides, there's links for those, and we're trying to include, which I'm trying not to overwhelm people with the links that we provide with our videos, but provide some jumping off points with different areas, learning labs that dive into topics. So there's tons of resources to dive deeper into any of these pieces.
Great. Hank, have a great weekend. Thanks again.
You too, David. Talk to you soon.